There is a story so old it has outlived every empire that once tried to claim it. A story of a civilization so advanced, so complete, that its disappearance left a silence no historian has ever fully explained. Plato wrote it down roughly 24 centuries ago, not as myth, not as allegory, but as a record, passed through generations, carried across the sea from Egyptian priests who spoke of it as history. Most scholars dismissed it. Some still do. But beneath the ocean floor, beneath layers of volcanic ash and ancient sediment, something keeps surfacing. Structures where there should be none. Coastlines that match no modern map. Geological events of a scale that could erase a world in a single afternoon. The story of Atlantis was never just a story. It was always a question. Around 360 BCE, in the city of Athens, a philosopher sat down and recorded something that would unsettle the world for the next 2.5 millennia. His name was Plato. He was not a poet composing fiction for an audience hungry for adventure. He was one of the most rigorous thinkers of the ancient world, a man devoted to reason, to precision, to the careful separation of truth from imagination. And yet, what he wrote in 2 of his dialogues, Timaeus and Critias, reads like nothing else in the philosophical canon. It reads like a report. The story appears without fanfare. Socrates is speaking with several companions, and one of them, Critias, mentions almost as an aside that he knows of a great historical event, one forgotten by the Athenians themselves. He says it was preserved in records kept by the Egyptians. The account had traveled, he explains, from the Egyptian city of Se, where priests had shown the Athenian statesman Solon ancient inscriptions describing a civilization of enormous power. Solon, one of the most respected figures in Greek history, brought the account back to Greece. It was passed down through his family, eventually reaching Critias, who now offers it to the gathering as a true story. His word, not allegory, not parable, but a true story. What follows is precise in a way that fiction rarely bothers to be. Plato gives measurements. He describes a city of concentric rings of land and water, alternating in perfect intervals, connected by tunnels carved through the rock. He describes a central island roughly 50 stades in diameter, approximately 9 kilometers, surrounded by rings of sea and land that extended outward in diminishing bands. He names the materials used in construction: white stone, black stone, red stone, quarried from beneath the central hill. He describes a metal called orichalcum, which gleamed like fire and covered the walls of the great temple. He gives the location of harbors, the dimensions of canals, the layout of the plain that extended to the south, rectangular in form, measuring 3,000 stades by 2,000 stades, protected from northern winds by mountains of exceptional height. This is not how myths are told. Myths do not include canal measurements. Myths do not specify the precise depth of a harbor or the exact alloy composition of a temple wall. The specificity is either the mark of a genuine source, a document, an inscription, a tradition with roots in something real, or it is the most elaborate and purposeful literary fiction in the ancient world. Both possibilities are worth examining carefully. Many scholars have argued for the fiction. The most common interpretation, advanced since the 19th century, is that Plato invented Atlantis entirely as a philosophical device, a warning about the corruption of power, the hubris of empire, the inevitable collapse of civilizations that lose their moral foundation. This reading has obvious appeal. It fits neatly into Plato's broader philosophical project. It explains why the story appears where it does, framed by discussions of the ideal state and the nature of justice, and it allows scholars to file the account under allegory and move on. But there are problems with that interpretation, and they are not small ones. The first is that Plato goes to unusual lengths to insist on the account's historical truth. In Timaeus, Critias explicitly says that the story is not invented, that it is a genuine record, that Solon himself verified its origins with the Egyptian priests and found it corroborated by written sources older than anything in Greece. Plato was not a writer who confused his readers about the difference between real and imagined. In the Republic, when he uses a myth, he says so. He calls it a myth. In Timaeus and Critias, he does not. The second problem is that the details Plato provides, the geology, the geography, the architectural specifics, are consistent with a genuine tradition of knowledge rather than invented symbolism. A philosopher constructing an allegory does not need to specify the color of the quarried stone or the width of the outer canal. Those details serve no symbolic purpose. They serve only one purpose, the preservation of an accurate description. And the third problem, perhaps the most persistent one, is that the world Plato describes, a large landmass in the Atlantic, destroyed by catastrophic geological events sometime around 9,600 BCE, has found, in the centuries since he wrote it down, a growing and quietly insistent body of evidence that something very much like it may have existed. The chain of transmission matters. Before Plato, before Critias, before even Solon's journey to Egypt, there were priests. And those priests were the custodians of something the Greeks had lost long before they knew it was gone. A continuous written record of the ancient world stretching back not centuries, but millennia. When Solon arrived in the Egyptian city of Sais, sometime around 590 BCE, he came as an admirer of Egyptian wisdom. He was already one of the most celebrated men in the Greek world, a lawgiver and poet whose reforms had reshaped Athenian society. But in Sais, surrounded by priests who had been maintaining their archives for longer than the Greek alphabet had existed, he was treated as something else entirely. He was treated as a child. The priests told him, with a gentleness that carried the weight of certainty, that the Greeks were young, not as an insult, but as a fact. They explained that Greece had been wiped clean by catastrophe, fire from the heavens, floods of enormous magnitude, so many times that no continuous memory survived. Each time civilization recovered in Greece, it recovered without the accumulated knowledge of what came before. The Egyptians, protected by their geography, by the desert to the west and the sea to the north, had been spared the worst of these catastrophes. Their records had survived. It is worth pausing on this for a moment, because the implications are larger than they first appear. The priests of Sais were not speaking in generalities. They were describing a specific mechanism, cyclical catastrophe, selectively preserved memory, that modern geologists and climate scientists would not have found entirely unreasonable. The Holocene epoch, which began around 11,700 years ago following the end of the last ice age, was marked by dramatic and rapid environmental changes. Sea levels rose by more than 100 meters in some regions over a period of several thousand years. Entire coastlines vanished. Ecosystems collapsed and reformed. What the Egyptian priests described as flood catastrophes, events that periodically erased the human record, corresponds with reasonable precision to what we now understand about the volatile early millennia of the current geological epoch. The priest then told Solon about a specific event, 9,000 years before their conversation, which would place it approximately 9,600 BCE. A great power had existed beyond the Pillars of Hercules, the ancient name for the Strait of Gibraltar. This power had dominated much of the Western Mediterranean and parts of what the priests called Libya and Europe. It had attempted to conquer the entire Mediterranean world, including Egypt and Athens, and it had been stopped not only by the resistance of the ancient Athenians who had fought it back according to the priest's account, but by something else, by the earth itself. In a single day and night of catastrophe, the power had collapsed into the sea, and the ocean had become impassable, choked with mud and shallow debris, for generations afterward. The phrase, "a single day and night," has attracted enormous scholarly attention. It could be literary convention, a poetic compression of events that unfolded over a longer period, but it could also be a precise description. There are geological events capable of producing landscape changes of continental scale in time frames measured not in centuries but in days. The collapse of a volcanic island, the rapid inundation of a low-lying landmass by rising seas, the subsidence of a coastal region along a fault line, all of these are capable of producing sudden and catastrophic results. The Egyptian priests, working from records rather than oral tradition, may have been describing exactly what they wrote. What is less often noted is the political detail embedded in the account. The priest told Solon that the ancient Athenians, a civilization that existed long before the Athens of Solon's time, had been the ones to resist the Atlantean advance. This is not a detail that serves Plato's allegorical purposes particularly well. If the story were invented as a philosophical warning, the heroes could have been anyone. The specific claim that Athens had once been a great military power in an age before recorded Greek history is an unusual thing to invent. It is, however, exactly the kind of claim that would be preserved in an Egyptian record, a neutral party with no reason to flatter the Greeks and every reason to record what the documents actually said. The Egyptians were meticulous archivists. The temple complex at Sais, known in ancient sources as a center of learning and record-keeping, maintained traditions of scholarship that predated Greece by thousands of years. When Herodotus visited Egypt roughly a century after Solon, he described priests who showed him written records extending back over 10,000 years. He was skeptical, as Greek historians tended to be about extraordinary claims, but he did not deny that the records existed. He saw them. They were there. What they contained, and what has been lost in the subsequent destruction of Egypt's temple libraries, remains one of the most consequential gaps in the human historical record. The date Plato gives is not approximate. He does not say long ago or in ancient times. He gives a number, 9,000 years before Solon's visit to Egypt. Since Solon traveled to Sais around 590 BCE, and Plato was writing around 360 BCE, the date of the Atlantean civilization and its destruction falls at approximately 9,600 BCE. This is not a date chosen at random, and it is not a date that can be dismissed as symbolic. It places the existence of Atlantis squarely at one of the most geologically turbulent periods in human prehistory, the boundary between the Pleistocene and the Holocene, the end of the last Great Ice Age. At 9,600 BCE, the world looked fundamentally different from the one we inhabit now. The The polar ice sheets, still retreating from their maximum extent roughly 20,000 years earlier, were releasing water into the oceans at rates that modern scientists have spent decades attempting to accurately measure. Sea levels globally were rising in some periods and regions by several meters per century. Large land masses that had been exposed during the Ice Age's peak, when sea levels were as much as 120 meters lower than today, were being swallowed by the advancing ocean. The coastlines of every continent were being redrawn, sometimes gradually, sometimes with violent suddenness, as ice dams failed and meltwater flooded continental shelves that had been dry land for tens of thousands of years. The event known as Meltwater Pulse 1A, which occurred between approximately 14,500 and 14,000 years ago, raised global sea levels by between 16 and 25 meters over a period of perhaps 500 years. A second major pulse, less precisely dated, may have occurred around 11,000 to 9,000 years ago. These were not slow, imperceptible changes. They were transformations on a scale that would have been visible within a single human lifetime. Coastlines retreating by miles, river deltas flooding, islands vanishing from the horizon over the course of generations. Any civilization living on low-lying coastal land during this period would have experienced exactly the kind of progressive, catastrophic inundation that Plato describes. The date 9600 BCE also corresponds with another significant event in Earth's geological record, the Younger Dryas impact hypothesis. Around 12,900 years ago, a period of rapid and dramatic climate cooling began, interrupting the relatively gradual warming that had been underway since the peak of the last ice age. This cooling event, known as the Younger Dryas, lasted for approximately 1,200 years before ending abruptly around 11,700 years ago, again with remarkable suddenness, with temperatures in Greenland rising by as much as 10 degrees Celsius within a decade. The cause of both the onset and the ending of the Younger Dryas remains debated, but a growing body of evidence, including the presence of extraterrestrial impact markers, including nanodiamonds, iridium, and platinum in sediment layers dating to the onset of the Younger Dryas, has led a number of researchers to propose that a cosmic impact or airburst event triggered the cooling. If such an event occurred, its consequences would have been catastrophic: massive wildfires, the rapid destabilization of ice sheets, flooding on a continental scale, the collapse of ecosystems, and the destruction, potentially within days or weeks, of any human settlements that happened to lie in the path of the resulting cataclysm. The date Plato provides, 9600 BCE, falls almost exactly at the end of the Younger Dryas, the moment when the Earth shifted abruptly back toward warmth, when ice sheets accelerated their melting, when sea levels rose most rapidly, when the coastlines of the world were most dramatically and permanently transformed. This is not coincidence easily explained away. A philosopher inventing an allegory around 360 BCE would have had no way of knowing that 9600 BCE was a geologically significant date. The science that has revealed the Younger Dryas and its boundaries did not exist until the 20th century. Ice core data from Greenland and Antarctica, which established the timeline of ancient climate events with remarkable precision, was not collected or analyzed until the 1960s and later. Plato could not have selected that date because it corresponded to a period of global catastrophe. He selected it because it was in the record he was working from. Modern geologists studying the period around 9600 BCE have documented evidence of catastrophic flooding events on multiple continents. The Black Sea, currently a saltwater body connected to the Mediterranean, was during the Ice Age a freshwater lake sitting well below the level of the Mediterranean. Around 7,500 years ago, according to research published by geologists William Ryan and Walter Pittman in the late 1990s, the natural land barrier separating it from the Mediterranean was breached, and salt water poured in with a force 200 times that of Niagara Falls. The lake expanded rapidly, swallowing settlements along its shores and pushing refugees in all directions. This event has been proposed as the origin of the flood myths common across cultures from the Middle East to Central Asia, but it occurred thousands of years after 9600 BCE, and it is not Atlantis. It is simply one data point in a broader pattern. The pattern of a world being remade by water, slowly and then all at once. The number 9,000 in Plato's account has also generated a separate line of inquiry. Some researchers have proposed that the Egyptian priests were not counting years but months, that the actual figure, converted from a lunar or seasonal counting system, should be divided by 12 or 13, placing the events roughly 700 to 900 years before Solon rather than 9,000. This would align the Atlantis account with the Bronze Age collapse of the late 2nd millennium BCE, a period of widespread civilizational destruction across the Mediterranean. The theory has some appeal, particularly because the Bronze Age collapse genuinely did involve the disappearance of advanced civilizations, the disruption of trade networks, and the sudden decline of literacy and monumental architecture across a wide region. But it requires assuming that the Egyptian priests, whose reputation for precision in record-keeping was observed and recorded by multiple ancient sources, made a systematic error in their own archives, or that Plato, who was otherwise meticulously precise, somehow misreported the unit of measurement given to Solon. Neither assumption is particularly convincing. The date stands, and what it points toward, a world in violent transition, a period of rising seas and collapsing coastlines, of ecosystems overturned and human settlements submerged, is a world in which the disappearance of a coastal civilization, even a large and sophisticated one, is not only possible, but almost statistically expected. Plato's description of Atlantis is not vague. It is, by the standards of ancient writing, almost architecturally precise. And when the geographical details are laid out systematically and compared against what we know of the Atlantic basin, the ancient Mediterranean world, and the topography of the ocean floor, the picture that emerges is not the map of a fantasy. It is the map of a place. According to the account in Critias, Atlantis was an island larger than Libya and Asia combined, or, depending on the translation, larger than Libya and Asia Minor combined. This has long been cited as evidence of invention, since no island of that size exists in the Atlantic. But the comparison may not have been intended as a measurement of absolute size. In ancient Greek geographical writing, Libya typically referred to the known northern coast of Africa, and Asia to the western coast of Anatolia, both relatively narrow coastal strips rather than entire continents. An island larger than Libya and Asia might mean something more modest than modern readers assume. A landmass of perhaps several 100,000 square kilometers, roughly equivalent to the Iberian Peninsula, or the area of the modern Caribbean archipelago if assembled into a single landmass. The location, according to Plato, was beyond the Pillars of Hercules, beyond the Strait of Gibraltar, in the open Atlantic. From this central island, the Atlanteans could reach other islands, and from those islands, one could reach the opposite continent, a phrase that has been interpreted, with great excitement by some researchers, as a reference to the Americas. This reading is not impossible. The geography of the Atlantic does include a chain of island stepping stones, the Azores, the Canary Islands, the Cape Verde Islands, that could, in principle, provide waypoints for transatlantic navigation. Whether any ancient civilization possessed the navigational capacity to cross the Atlantic remains debated, but the crossing is not physically impossible. And there is a growing body of evidence, botanical, genetic, and archaeological, suggesting that pre-Columbian contact between the Old World and the Americas may have occurred. The central city of Atlantis, as Plato describes it, was built on a hill rising from a coastal plain. The hill was encircled by alternating rings of land and sea, 3 rings of water and 2 of land, the whole structure artificial in origin, carved, according to the account, by the god Poseidon himself, but interpreted by researchers as a description of massive engineering works. The outermost ring of sea was 3 stades wide, the next ring of land 2 stades, the innermost ring of sea 1 stade, and the central island itself 5 stades in diameter. A stade is approximately 185 meters. The total diameter of the entire ringed complex would therefore have been roughly 3 kilometers. An enormous, but not geologically implausible structure. To the south of the city, protected by mountains to the north, lay a great rectangular plain. Plato gives its dimensions as 3,000 stades by 2,000 stades, approximately 550 by 370 kilometers. This plain was surrounded by a ditch, itself of remarkable dimensions, 100 feet deep, a stade wide, and 3,000 stades in length along its perimeter. The plain was divided into allotments, each responsible for providing soldiers and resources in proportion to its size. The entire system reads like an administrative record rather than a literary invention, a description of agricultural and military organization specific enough to suggest it was drawn from an actual source. What is striking, when these dimensions are mapped against the known seafloor topography of the Atlantic, is that the region Plato describes, a large elevated plain to the southwest of the Iberian Peninsula, beyond the Strait of Gibraltar, corresponds to an area of the Atlantic seafloor known as the Azores Plateau. This plateau, which sits at depths ranging from a few hundred to several thousand meters below the current ocean surface, is a geologically unusual feature. A broad, relatively flat, elevated region sitting atop the mid-Atlantic ridge where 3 major tectonic plates meet. It is one of the most volcanically and seismically active regions in the Atlantic basin. And during the peak of the last ice age, when sea levels were 120 meters lower than today, portions of this plateau would have been above the surface, not as dry land in the conventional sense, but as shallow, navigable coastal shelves that could have supported human settlement. The Azores Islands themselves are the visible peaks of this submerged plateau. When researchers use bathymetric maps, detailed measurements of ocean floor depth, to reconstruct what the region would have looked like at lower sea levels, the result is an archipelago of interconnected islands and shallow banks considerably larger than the current Azores, not a continent, but a significant landmass, one that sits with almost uncomfortable precision in the area Plato described. There is a geological formation on the seafloor southwest of the Azores known as the Ampere Seamount. In 1974, a Soviet oceanographic expedition reported finding what appeared to be worked stone on the summit of this seamount, rectangular blocks at a depth of approximately 200 meters. The discovery was reported in Soviet scientific journals and was initially met with cautious interest. Subsequent expeditions to the area have not definitively confirmed or refuted the finding. The blocks, if they exist as described, could be natural basalt formations. Columnar basalt frequently forms geometrically regular structures that can resemble cut stone, but they could also be something else. The question has not been closed. The ocean does not announce itself. It does not give warning, does not negotiate, does not pause at the edge of a settlement to allow for evacuation. When a coastline is lost to rising water, it is lost across timescales that can range from the geological meters per millennium to the catastrophic meters per hour. The distinction matters enormously. A civilization adapted to slow coastal loss has time to move, to rebuild further inland, to carry its records and its knowledge with it. A civilization struck by rapid inundation has none of those advantages. The geological record of the period between 12,000 and 8,000 years ago is a record of both kinds of loss, sometimes overlapping. The same era that saw the gradual retreat of glaciers and the steady rise of sea levels also saw episodes of sudden, violent flooding. The most dramatic of these was the drainage of the great proglacial lakes of North America. Vast bodies of meltwater impounded behind natural ice dams, sometimes holding volumes of water comparable to modern seas. When those dams failed, as they did on multiple occasions, the water moved across the landscape with a force that carved the topography of continents. The channeled scablands of Washington State, a region of deeply gouged bedrock channels and dry cataracts extending over hundreds of kilometers, were formed not by slow erosion, but by a flood of such magnitude that when geologist J. Harlan Bretz first proposed it in the 1920s, his colleagues refused to believe him. They called the idea unscientific. 4 decades later, when the evidence became impossible to ignore, Bretz was vindicated. The flood had been real. It had happened in days. Lake Agassiz, the largest of the North American proglacial lakes, may have drained catastrophically on more than one occasion. Its drainage has been linked to the onset of the Younger Dryas cooling event, with some researchers arguing that the sudden influx of enormous volumes of cold fresh water into the North Atlantic disrupted the ocean circulation system, specifically the Atlantic meridional overturning circulation, the system of currents that today keeps northwestern Europe significantly warmer than its latitude would otherwise allow, triggering rapid and widespread climate change. If this disruption was severe enough, it could have produced atmospheric and oceanic effects far beyond North America, affecting civilizations on both sides of the Atlantic. For a coastal civilization living in the Atlantic basin at this time, the consequences of such an event would have been difficult to separate from simple catastrophe. Sudden sea level rise, disrupted weather patterns, failure of agricultural systems adapted to a climate that no longer existed, flooding of lowland settlements at the margins of the sea. These are the kinds of events that do not appear in written records because written records did not yet exist. or because the civilizations that might have kept them were among those that did not survive. The submergence of inhabited land is not a theoretical concern. It is documented. The North Sea, which today separates Britain from continental Europe, was during the last ice age a vast low-lying plain known to archaeologists as Doggerland. This region, which extended across what is now the southern North Sea from the coast of modern-day Denmark to the coast of England, was inhabited by Mesolithic hunter-gatherers for thousands of years. It had rivers, lakes, wetlands, and coastlines. And between roughly 10,000 and 6,000 years ago, it was steadily inundated by the rising North Sea, disappearing entirely beneath the water. Archaeologists have dredged Mesolithic artifacts from the seafloor, tools, animal bones, peat from ancient wetlands, confirming that people lived and died on land that is now 30 meters below the surface of the sea. Doggerland was not Atlantis, but it demonstrates with the precision of recovered physical evidence that entire inhabited regions can vanish beneath the ocean within time frames that human memory can span. The specific mechanism of Atlantis's destruction, as Plato describes it, is a combination of earthquake and flood. Seismic activity followed or accompanied by inundation. This combination is not unusual in the geological record. Submarine landslides triggered by earthquakes can produce tsunamis of enormous scale. The collapse of volcanic islands, which are inherently unstable structures built on the accumulation of erupted material, can produce similarly catastrophic displacement waves. The island of Krakatoa, when its volcanic cone collapsed into the sea in 1883, generated a tsunami that killed more than 30,000 people along the coasts of Java and Sumatra. The Storegga Slide, a massive submarine landslide off the coast of Norway that occurred approximately 8,200 years ago, generated a tsunami that may have sent waves up to 20 meters high across the coastlines of Scotland, Norway, and Iceland, and which would have struck Doggerland at a time when it was still partially inhabited, potentially contributing to its final inundation. If a comparable event had struck a civilization living on low-lying Atlantic coastal land around 9,600 BCE, seismic disruption, volcanic collapse, catastrophic flooding, the result would have been precisely what Plato describes: the loss of a landmass within a very short period of time beneath the surface of the sea. Every ancient account has an anchor, a fixed point from which the rest of the geography extends. For Plato's Atlantis, that anchor is the Pillars of Hercules, the pair of promontories that flank the Strait of Gibraltar, where the Mediterranean opens into the Atlantic. They were the edge of the known world for the ancient Greeks. Beyond them lay open ocean, uncharted water, the vast and largely unknown Atlantic. And it is precisely there, beyond that threshold, that Plato places Atlantis. The Pillars of Hercules are not symbolic in this context. They are a specific geographical marker, one that every ancient reader would have recognized immediately. Plato's audience knew exactly where the pillars were. They knew that beyond them lay the outer sea, the Atlantic, and they knew that the waters beyond Gibraltar were considered dangerous, unpredictable, and largely unnavigable by Greek standards. To place Atlantis beyond the pillars was to place it in a real location, a location outside the familiar world, yes, but real. This placement carries significant implications. It means that Plato was not describing something in the Mediterranean. Every candidate for Atlantis that has been proposed within the Mediterranean basin, and there have been many, from Crete to Cyprus to the coast of Tunisia, requires either ignoring or reinterpreting the explicit geographical statement that Atlantis lay outside the Strait of Gibraltar. Some researchers have argued that the Pillars of Hercules in Plato's time referred to different landmarks than the Strait of Gibraltar, perhaps to promontories in the Tunisian coastline or to points within the Aegean. But the ancient sources are consistent. The Pillars of Hercules were Gibraltar. They had been since at least the 6th century BCE, and Plato was explicit. Beyond the pillars, the ancient account continues, Atlantis controlled a domain that extended across what the priests called Libya and Europe, meaning, in approximate ancient terms, the coastal regions bordering both the southern and northern shores of the Atlantic. This is an enormous territorial claim, and it has been treated with skepticism by scholars who note that no archaeological evidence of such a widespread empire has been found. But it is worth considering what kind of evidence such a civilization would have left, and where that evidence might now be. A civilization whose heartland lies beneath the ocean, whose coastal settlements were inundated by rising seas, and whose surviving refugees dispersed across multiple continents would leave a diffuse and fragmented record, precisely the kind of record that is difficult to recognize as unified, precisely the kind of evidence that gets attributed to separate, unconnected cultures. The Atlantic itself, as a body of water and as a geographical and cultural boundary, has been underestimated as a zone of ancient human activity. The standard model of human prehistory places the first crossing of the Atlantic in 1492 CE, but that model has been challenged repeatedly by anomalous findings. South American sweet potatoes found in Polynesia dated to pre-Columbian contact. Cocaine and tobacco residues identified in Egyptian mummies of the New Kingdom period. Genetic evidence of pre-Columbian contact between Amazonian populations and populations in Australasia. None of these findings have been fully explained by the standard model. All of them suggest that the ocean, ancient populations possessed resources and navigational knowledge that allowed for more complex and far-reaching maritime activity than has been traditionally assumed. The Phoenicians, who flourished from roughly 1500 to 300 BCE, were known in ancient sources to have sailed beyond the Pillars of Hercules. Herodotus records that a Phoenician fleet circumnavigated Africa around 600 BCE on commission from the Egyptian pharaoh Necho II, a journey that, if accurate, would have required sustained deep water navigation far beyond any route previously credited to ancient mariners. The Carthaginian explorer Hanno is recorded as having sailed down the west coast of Africa as far as the Gulf of Guinea, roughly 4,000 kilometers beyond Gibraltar. These are historical records, not myths. They describe a world in which the Atlantic was not an impassable barrier, but a navigable, if challenging, body of water, one that sophisticated maritime cultures could and did enter. If Phoenician and Carthaginian navigators could reach the coasts of Africa and possibly beyond in the first millennium BCE, what might a more ancient maritime civilization, one with several centuries of accumulated navigational knowledge, one that according to Plato had controlled the waters immediately beyond Gibraltar, have been capable of? The question is not rhetorical. It has a direction. In the late summer of 2001, a team of researchers working for a Canadian exploration company was conducting sonar surveys of the ocean floor off the western coast of Cuba in the Yucatan Channel. They were looking for Spanish colonial shipwrecks. a routine, if specialized form of underwater archaeological survey. What the sonar returned was not a shipwreck. It was a pattern. Regular geometric forms, repeating structures, what appeared to be a grid of stone blocks and rectilinear formations spread across a plateau on the seafloor at a depth of between 600 and 750 meters. The area covered was approximately 2 square kilometers. The team, led by Paulina Zalitsky and Paul Weinsweig, returned with remotely operated vehicles and filmed what they had found. The footage showed what appeared to be large, smooth stone blocks arranged in rectilinear patterns. Some appeared to be pyramidal in form. Others showed what the researchers described as circular and cruciform shapes. Zalitsky stated publicly that the formations resembled an urban complex. Roads, buildings, pyramidal structures of a scale and regularity inconsistent with known natural geological processes. The site received significant media attention in 2001 and 2002, and then largely it went quiet. The scientific community's response was cautious, as it generally is with such discoveries, and for defensible reasons. Geology is capable of producing remarkably regular structures that resemble human construction. Basalt frequently fractures into columnar and rectilinear forms. Submarine landslides can arrange rock in patterns that suggest regularity. Without physical samples, core samples, material analysis, it is not possible to confirm whether a formation is natural or constructed. The depth of the Cuban site, between 600 and 750 meters, places it well beyond the reach of conventional dive operations and makes systematic investigation extremely difficult and expensive. No comprehensive archaeological survey of the site has been completed, but the depth itself is significant. At 600 to 750 meters below current sea level, the site would have been above water only during the most extreme glacial maximum, when sea levels were at their lowest, not at 9,600 BCE, when sea levels were already rising, but considerably earlier. If the formations are artificial, they represent a civilization of considerable antiquity, one that predates not only the traditional timeline for complex civilization, but potentially the timeline for the human colonization of the Americas by the land bridge across what is now the Bering Strait. This is where the Cuban site becomes genuinely difficult to categorize. It is either a remarkable and significant natural geological feature, or it is evidence of human construction so ancient that it would require a fundamental revision of the accepted timeline of human civilizational development in the Americas. The available evidence is insufficient to determine which, but the available evidence is also insufficient to dismiss it. The Cuban site is not isolated. Across the Atlantic basin and its margins, researchers and divers have documented formations that resist easy natural explanation. Off the coast of Japan, near the island of Yonaguni, a large submerged rock formation was discovered in 1987. The Yonaguni Monument, as it is now known, consists of a series of terraced stone platforms, sharp angular cuts, and what appear to be steps and channels, descending from a depth of approximately 5 meters to 27 meters below the current sea surface. The site sits at a depth that would have placed it above water roughly 10,000 years ago. Japanese geologist Masaki Kimura, who has studied the site extensively, argues that the formations show clear evidence of human modification, tool marks, regular angles, and a coherence of design inconsistent with natural erosion. Other geologists have argued that the formations, while unusual, can be explained by the natural fracturing and erosion of sandstone. The debate continues. Off the coast of India, in the Gulf of Kambat, formerly known as the Gulf of Cambay, sonar surveys conducted in 2001 by India's National Institute of Ocean Technology revealed two large submerged sites at depths between 5 and 40 meters. The surveys returned acoustic images of what appeared to be large, regularly structured formations extending across several kilometers, at depths consistent with pre-inundation habitation during the early Holocene. Subsequent dredging operations recovered artifacts from the site, including worked wood dated by radiocarbon to approximately 9,500 years ago, placing the site's occupation firmly in the period corresponding to Plato's Atlantis date. Whether the formations themselves are natural or constructed remains contested. The presence of worked material, however, is not disputed. People were there. The pattern across these sites is not uniform enough to constitute proof, but it is consistent enough to constitute a question that deserves a better answer than it has so far received. There is a formation in the Sahara Desert of northwestern Mauritania that looks, from the sky, like a target. A series of concentric rings eroded into the ancient rock of the desert plateau, extending across nearly 50 kilometers of otherwise flat terrain. It is visible from space. It has been used by astronauts as a navigational landmark. Geologists call it the Richat structure, or sometimes the Eye of the Sahara. For most of the 20th century, it was classified as a meteor impact crater, an obvious explanation for a circular, ring structure of that scale. That explanation was later revised. The geology of the Richat structure does not show the shock metamorphism characteristic of meteor impacts. Current geological consensus classifies it as a symmetrical anticline, a dome of rock that has been differentially eroded over millions of years, with harder rock layers forming the concentric rings and softer layers eroding away between them. It is, in the geological mainstream, a beautiful and unusual natural formation with no connection to human history. But, in recent years, a different line of inquiry has emerged, driven not by professional geologists, but by researchers working at the intersection of ancient history and physical geography. Their argument, first articulated in popular form around 2018 and subsequently developed in considerable detail, is that the Richat structure bears a remarkable structural correspondence to Plato's description of the city of Atlantis. The correspondence is not superficial. Plato describes concentric rings of land and water alternating across a total diameter of roughly 27 kilometers for the ringed city complex, set within a larger plain protected by mountains to the north. The Richat structure has concentric rings with an outer diameter of approximately 50 kilometers, somewhat larger than Plato's description, but within the range of possible translation errors from ancient units of measurement. The structure sits within a low-lying region of the Sahara at an elevation of roughly 400 meters above current sea level. It is surrounded on its northern edge by the Atlas mountain range, which matches Plato's description of mountains protecting the city from northern winds. The plain to the south of the structure is vast and relatively flat, consistent with the agricultural plain described in Critias. The critical challenge for this hypothesis is obvious. The Richat structure is in a desert, not the Atlantic Ocean. Plato is unambiguous that Atlantis was an island, that it lay beyond the Pillars of Hercules, and that it sank beneath the sea. How does a geological feature in the middle of northwestern Africa account for any of that? The researchers proposing the Richat hypothesis have an answer to this, and it is geologically more interesting than it might initially appear. The Sahara Desert, today one of the driest places on Earth, was not always desert. During the African humid period, which lasted from approximately 11,000 to 5,000 years ago, a period that corresponds closely to the post-Younger Dryas warming and to the general time frame of Plato's Atlantis. The Sahara was a fundamentally different environment. It was greener, wetter, and more habitable than at any time in the last 100,000 years. Lake Chad, today a shrinking remnant in the southern Sahara, was during this period an inland sea of enormous dimensions, sometimes referred to by researchers as Mega Lake Chad, covering an area comparable to the Caspian Sea. Other large water bodies existed across what is now the Saharan interior. River systems carried water from the Atlas Mountains southward across the Saharan plain. The region that is now desert was, for several thousand years, a landscape of grasslands, lakes, rivers, and inhabited terrain. If the Richat structure was occupied during the African humid period, it would have sat at the edge of a large, shallow inland sea, or been surrounded by navigable water entirely, depending on the extent of the flooding. The Atlas Mountains to the north would have provided exactly the shelter from northern winds that Plato describes. The concentric ring structure of the terrain would have been visible and utilizable as a natural foundation for construction. And at the end of the African humid period, around 5,000 years ago, the drying of the Sahara, itself a rapid climatic transition, sometimes called the 5.9 kiloyear event, would have rendered the region uninhabitable within centuries, driving any remaining population northward toward the Mediterranean coast or westward toward the Atlantic. None of this places Atlantis in the Richat structure conclusively. The geological timeline does not perfectly match Plato's date. The concentric rings are larger than described, and the location requires significant reinterpretation of the island in the sea description. But the structural correspondence is striking enough that it cannot be dismissed without careful consideration. It raises a question that cuts across the entire Atlantis inquiry. How precisely do we trust Plato's geographical framework, and how much of it might have been distorted in transmission across centuries and languages before it reached him? Around 1600 BCE, a volcano in the southern Aegean Sea did something that permanently altered the history of the eastern Mediterranean world. The island of Thera, today known as Santorini, underwent one of the most powerful volcanic eruptions of the Holocene epoch. The eruption, now classified as a Plinian event of significant magnitude, ejected an estimated 60 cubic kilometers of material into the atmosphere. It collapsed the central portion of the island into the caldera below, generating tsunamis that moved across the Aegean and eastern Mediterranean at speeds of several hundred kilometers per hour. The ashfall from the eruption has been identified in ice cores from Greenland and in sediment layers across the Mediterranean, Anatolia, and the Nile Delta. The consequences for the civilization of Crete, the Minoan culture, one of the most sophisticated of the Bronze Age Mediterranean world, were catastrophic and, in the long historical view, terminal. Minoan civilization, which had flourished for roughly 1,500 years, producing monumental palace complexes, sophisticated art, a writing system, and extensive maritime trade networks, did not survive the volcanic event in its original form. The precise timeline and causality of the Minoan collapse remains debated among archaeologists. The eruption may have been followed by a century or more of gradual decline before the final disappearance of Minoan political structures. But the connection between the Thera eruption and the end of Minoan civilization is broadly accepted. The Thera eruption hypothesis for Atlantis was proposed most prominently by the Greek archaeologist Spyridon Marinatos in the 1930s and was subsequently developed by a number of researchers, most notably the classical scholar J.V. Luce in the 1960s. The argument runs as follows. The Minoan civilization, centered on Crete and the surrounding Aegean islands, was indeed an advanced Bronze Age maritime culture whose sudden collapse might have been transmitted into Egyptian records as the destruction of a great island civilization. The priests of Sais, working from their archives, may have preserved a genuine memory of the Minoan collapse, the volcanic destruction of Thera, the subsequent decline of the Cretan palace culture, and transmitted it to Solon as the story of Atlantis. This hypothesis has several genuine strengths. The Minoan civilization was real, advanced, maritime, and genuinely destroyed in a manner consistent with catastrophic geological events. Egyptian records do reference the Minoan world. The Egyptians called the people of the Aegean islands the Keftiu, and artistic representations of what appear to be Minoan traders appear in New Kingdom tomb paintings. A cultural memory of Minoan collapse in Egyptian records is plausible, and the Aegean islands are, by the standards of ancient Egyptian geographical knowledge, located to the northwest, broadly consistent with the direction Plato implies. But the hypothesis also has serious problems that have prevented it from achieving scholarly consensus. The first is chronological. The Thera eruption occurred around 1600 BCE. Solon visited Egypt around 590 BCE, approximately 1,000 years later. Plato's account specifies 9,000 years before Solon, not 1,000. If the Egyptian priests were describing the Thera eruption, they were off by a factor of 9 in their own records. A remarkable error for an archival tradition celebrated in antiquity for its precision. The factor of 10 conversion theory, that the priests were counting in lunar months and Solon misunderstood, would reduce 9,000 years to approximately 700 years, bringing the timeline closer to the Thera eruption. But even this requires assuming a systematic misunderstanding in a well-documented archival tradition. The second problem is geographical. Crete and the Aegean islands are inside the Pillars of Hercules, not beyond them. Plato's statement about the location of Atlantis is unambiguous. The Minoan world, however spectacular its achievements, does not fit the stated geography. Some researchers have argued that beyond the pillars was a later addition or geographical error in transmission. But to accept that argument is to accept that Plato's account has been so significantly altered from its original form that almost any geographical location could be proposed as a candidate, which is precisely the kind of unfalsifiable reasoning that serious historical inquiry must avoid. The Thera hypothesis captures something real and important. The Aegean Bronze Age produced civilizations of a complexity and sophistication that their successors largely forgot, and their catastrophic end genuinely did leave a gap in the Mediterranean world's cultural memory. But it does not account for Atlantis. It accounts for a different memory, perhaps preserved in the same Egyptian archives, perhaps transmitted separately, of a real destruction that changed the Eastern Mediterranean world. The two memories may have influenced each other. They are not the same thing. What the Thera discussion contributes to the broader inquiry is a demonstration of principle. Complex civilizations do collapse, and their collapses can be catastrophic enough to erase the memory of their existence within a few generations. The Minoans, whose administrative system used a writing script, linear A, that has never been deciphered, left a cultural record so fragmentary that we cannot read their language, cannot access their literature or their history in their own words, cannot know what they called themselves or what they believed about their own origins. They existed for 15 centuries and vanished into a silence almost as complete as the one Plato describes. In 1513, an Ottoman admiral and cartographer named Piri Reis completed a world map. The map, drawn on gazelle skin and incorporating information from multiple older sources, some of which Piri Reis himself identified as ancient, depicted the coastlines of the Atlantic world with a fidelity that, for its time, was extraordinary. The northern coastlines of Europe and Africa were rendered with reasonable accuracy, consistent with the navigational knowledge of the early 16th century. The coastline of South America, which had only recently entered European geographical awareness following Columbus's voyages, was also represented. And here, the map begins to become interesting. The South American coastline on the Piri Reis map was rendered with a precision that exceeded what 16th century European cartographers should have been capable of. The general shape of the continent, the orientation of its eastern coast, the location of major rivers and coastal features, all were depicted with an accuracy that would have required extensive surveying of the kind that did not occur until considerably later in the colonial period. This has attracted attention from researchers since the map was rediscovered in the Topkapi Palace in Istanbul in 1929. More striking still is what appears at the bottom of the map, a coastline extending from the southern tip of South America that has been interpreted by some researchers, most prominently the American historian Charles Hapgood in his 1966 book, Maps of the Ancient Sea Kings, as a depiction of Antarctica. The Antarctic continent was not officially discovered until 1820, more than 3 centuries after Piri Reis completed his map. The coastline depicted at the bottom of the map corresponds, in Hapgood's analysis, not to the current ice-covered coastline of Antarctica, but to the subglacial coastline, the shape of the land beneath the ice, which was not accurately determined until seismic surveys in the 20th century. If Hapgood's interpretation is correct, the Piri Reis map preserves geographical information of a coastline that was last accessible, free of permanent ice cover, during the early post-glacial period, roughly 10,000 years ago. Hapgood's analysis has been disputed extensively, and some of the disputes have been well-founded. Several of his specific geographical identifications have been challenged by cartographers who argue that what he interprets as Antarctica is simply a distortion of the known southern coastlines of the Americas, stretched and repositioned by the projection techniques of the time. The history of early modern cartography is full of similar distortions, and the absence of Antarctica from most contemporary maps does not necessarily mean its presence on this one requires a prehistoric source. These are legitimate objections, but the Piri Reis map is not the only anomalous cartographic document from the early modern period. The Orontius Phineus map of 1531 also depicts a southern landmass with a shape and orientation that Hapgood argued corresponds to Antarctica without its ice sheet. The Bouache map of 1737 shows a similarly positioned landmass, divided into two land areas separated by a channel, a feature that corresponds, according to modern subglacial surveys, to the actual topography of Antarctica beneath the ice. These maps, taken individually, can each be explained as projective distortions or speculative additions to fill cartographic blank spaces. Taken together, they suggest a pattern of transmitted geographical knowledge that does not have a simple explanation within the standard history of cartography. Piri Reis himself, in notes accompanying his map, stated that he had compiled it from approximately 20 source maps, including maps from the time of Alexander the Great, and what he described as Arabic maps of great antiquity. He does not name these sources precisely enough to allow independent verification, but the claim that his map incorporated ancient source material is consistent with the cartographic practices of the Ottoman world, which maintained libraries of accumulated geographical knowledge from Greek, Arab, and other traditions that have largely been lost in the West. The implications for the Atlantis inquiry are not direct. A map showing accurate pre-glacial Antarctic coastlines does not prove that Atlantis existed. What it suggests, and this is a more modest but still significant claim, is that the ancient world may have possessed geographical knowledge of coastlines that no longer exist in the forms depicted, knowledge that was accumulated through processes we do not currently understand and transmitted through archival traditions whose contents we have largely lost. If such knowledge existed regarding Antarctica, it is not unreasonable to ask whether comparable knowledge might have existed regarding other now submerged or dramatically altered coastlines, including those of the Atlantic basin during the early post-glacial period. Civilizations that collapse do not disappear entirely. Their people move. They carry with them their languages, their agricultural techniques, their cosmologies, their genetic heritage. The fall of a civilization leaves survivors, and those survivors leave traces in the archaeological record, in linguistic structures, in the human genome. If Atlantis was a real civilization that collapsed catastrophically around 9,600 BCE, its survivors would have dispersed across the Atlantic world, and they would have left exactly these kinds of traces. The question is whether the traces that exist are consistent with such an event. Population genetics has transformed the study of human prehistory over the last 3 decades. The ability to extract and sequence ancient DNA from archaeological remains, bones, teeth, the residues of organic material in burial sites, has allowed researchers to reconstruct population movements with a precision that was simply not available to previous generations of scholars. The results have repeatedly surprised researchers trained on the traditional archaeological consensus. Populations that appeared, from the material record, to be continuous and stable have turned out, genetically, to show dramatic discontinuities, sudden replacements, or significant admixtures that indicate large-scale population movements not previously suspected. One of the most significant genetic events of the early Holocene was the spread of what geneticists call Western hunter-gatherer ancestry across Europe. This population, which carried a distinctive suite of genetic variants, had been present in Europe during the Upper Paleolithic and appears to have expanded significantly following the retreat of the glaciers. But the pattern of their expansion and subsequent replacement, first by early European farmers arriving from Anatolia around 8,000 years ago, and then by steppe herders arriving around 4,500 years ago, suggests a series of large-scale population movements whose origins and causes are only partially understood. Each of these movements brought not just new genes, but new technologies, new agricultural systems, new languages. The timing and direction of these movements is consistent with refugees from disrupted coastal civilizations. If a maritime culture living on low-lying Atlantic coastal land was displaced by rising seas and geological catastrophe around 9,600 BCE, the most logical direction of movement would have been inland and northward, into the interior of the Iberian Peninsula and Western Europe, into the coastal regions of North Africa, into the islands of the Mediterranean. These are precisely the regions where the Western hunter-gatherer genetic signature is most prominent in the post-glacial archaeological record. The Basque people of northern Spain and southwestern France represent one of the most genetically distinctive populations in Europe. Their language, Euskara, is a language isolate, unrelated to any other known language family, living or extinct. Its origins are completely unknown. Genetic studies have shown that the Basque population carries an unusually high proportion of Western hunter-gatherer ancestry compared to their neighbors, suggesting that they represent a relatively undiluted remnant of a pre-farming Atlantic European population. Their geographical location on the Atlantic coast of southwestern Europe, near the Pyrenees, at the far western edge of the continental landmass, places them in exactly the region where survivors of a displaced Atlantic coastal civilization might be expected to have settled. In the Americas, genetic evidence has revealed patterns of population structure and movement that do not conform entirely to the simple land bridge migration model. A 2015 study published in the journal Nature found evidence of an unexpected genetic signal in certain Amazonian populations, specifically the Suruí and Caritiana of Brazil, that showed affinity to populations in Australasia and South Asia rather than to the East Asian ancestry expected from Siberian migrants crossing the Bering Land Bridge. This signal, which the researchers termed population Y, appears to represent a separate and earlier migration into the Americas by a population whose origins and route remain unclear. If population Y represents a maritime migration rather than a land bridge crossing, a hypothesis consistent with the genetic data, though not the only explanation, it would require a rethinking of the routes by which people first reached the Americas, and potentially a rethinking of who was sailing the world's oceans at an earlier date than current consensus allows. None of this genetic evidence proves Atlantis, but it reveals a prehistoric world of movement, displacement, and cultural transmission considerably more complex than the traditional models have allowed. Survivors of a destroyed coastal civilization dispersing across multiple continents would leave exactly this kind of diffuse and difficult to interpret genetic signature present everywhere and definitively attributable to a single source nowhere. There are approximately 200 documented flood myths from cultures distributed across every inhabited continent. They come from Mesopotamia and India, from Greece and Scandinavia, from the indigenous cultures of North and South America, from the Aboriginal traditions of Australia, from the oral histories of Pacific Island cultures. They come from cultures that had no historical contact with each other before the modern era. And while they differ in their details, the name of the survivor, the nature of the divine warning, the duration of the flood, the eventual landing place of the vessel. They share a structural core, a catastrophic inundation of the known world, the survival of a small number of people, and the subsequent rebuilding of civilization from survivors who carry with them the memory of what was lost. The near universality of flood mythology has been explained in several ways. The most reductive explanation is simply that floods are common. Rivers overflow, coastlines flood, agricultural settlements are periodically inundated, and the emotional impact of these local events is sufficient to generate mythology. This explanation is plausible for individual myths. It becomes less satisfying when applied to the global pattern. A local river flood in ancient Mesopotamia might explain the Epic of Gilgamesh's flood narrative. It does not explain why the Hopi people of the American Southwest, the Tlingit people of the Pacific Northwest, the Mapuche of Chile, the Yoruba of West Africa, and the Tamil people of southern India all preserved strikingly similar flood traditions independently. The more structurally convincing explanation, proposed by researchers including Joseph Campbell, Adrian Mayer, and more recently by geologist Robert Schoch, is that the flood myths preserve a genuine collective memory of the actual inundations that accompanied the end of the last ice age. As sea levels rose by more than 100 meters over several thousand years, as coastlines retreated by hundreds of kilometers in low-lying regions, as once familiar landscapes disappeared beneath water, the human communities that witnessed these changes encoded them in narrative, in the only archival technology available to pre-literate cultures: story. The Mesopotamian flood tradition, most fully expressed in the Babylonian Atrahasis epic and in the flood narrative of the Epic of Gilgamesh, dates in its written form to approximately 1700 BCE. But the textual tradition clearly draws on older oral sources, and some researchers have traced specific elements of the narrative: the rectangular arc, the release of birds to test for land, the landing on a mountain, to traditions that may predate the cuneiform writing system itself. The Sumerian king list, a document recording the reigns of Mesopotamian rulers from legendary antiquity to historical times, explicitly divides history into two eras: before the flood and after the flood. The kings who ruled before the flood are credited with reigns of tens of thousands of years, clearly mythological in their specifics. But the structural claim that the flood was a real historical boundary separating an earlier world from the one that followed is embedded in a document that otherwise records verifiable historical information. The flood narrative in Hindu tradition, the story of Manu and the great fish who warns him of the coming deluge, appears in texts of considerable antiquity. The Shatapada Brahmana, which dates in its written form to roughly 800 BCE, but which scholars believe preserves far older oral traditions. The story's structure is identical to the Mesopotamian version in its essentials: a divinely warned survivor, a vessel, a catastrophic flood, a landing, a new beginning. The geographical and cultural distance between ancient India and ancient Mesopotamia makes independent invention plausible, but it also makes a shared source plausible: a common origin in a genuine prehistoric event whose memory dispersed with the cultures that survived it. The Greek tradition adds a specific geographical detail of interest. In the flood story of Ogyges, a king of Boeotia or Attica, the flood is described as covering all of Greece and as occurring in a time before the establishment of the Greek city-states, in the deep prehistorical past. In the story of Deucalion, the Greek analogue of Noah, the flood is again universal, destroying all of civilization except for the survivors who land on Mount Parnassus. Plato himself references the Deucalion flood in the Timaeus in the very passage where the Egyptian priest explains to Solon that the Greeks have lost their memory of earlier events because of periodic catastrophes. The priest does not say the flood myths are false. He says they preserve an incomplete memory of something real. What is preserved across all of these traditions, Mesopotamian, Indian, Greek, Mesoamerican, Aboriginal Australian, is not the specific event, but the experience of the event. The sudden loss of a world, the desperate survival of a remnant, the attempt to rebuild from almost nothing. If Atlantis was real, its destruction was one node in a broader catastrophe that affected multiple coastal civilizations around the world during the same general period. The myths are not all about Atlantis. They are all about the same thing that happened to Atlantis. The civilization Plato describes was not primitive. It was a culture capable of large-scale hydraulic engineering, the construction of a system of concentric canals and ringed land masses that required precise surveying, coordinated labor over generations, and a sophisticated understanding of water management. It was a culture that quarried stone in multiple varieties and used them deliberately. The combination of white, black, and red stone mentioned in Critias suggests an aesthetic as well as a structural intention, a civilization that thought about the visual impact of its built environment. It was a culture with metallurgical knowledge, the mysterious orichalcum, described as more valuable than anything except gold, implies a mastery of alloy production, and it was, according to the account, a maritime civilization of the first order, controlling naval routes across an ocean. How does this description compare with what we know of civilizations that existed in the same approximate time frame? The standard answer for most of the 20th century was, it doesn't compare at all. By 9600 BCE, the conventional timeline of human civilizational development placed all of humanity in a pre-agricultural, pre-ceramic, pre-metallurgical phase, scattered hunter-gatherer bands, living in temporary shelters, without writing, without cities, without the kind of organized labor that large-scale construction requires. Atlantis, in that context, was simply impossible. The timeline didn't allow for it, but the timeline has been revised, and the revisions have been significant. The most dramatic revision came from Göbekli Tepe, a site in southeastern Turkey where, beginning in 1994, excavations led by German archaeologist Klaus Schmidt revealed a complex of massive stone enclosures, their pillars carved with intricate relief sculptures of animals and abstract symbols dating to between 9,600 and 8,200 BCE. The site predates Stonehenge by 6,000 years. It predates the domestication of wheat, which occurred in the same region roughly 2,000 years later, and therefore predates settled agricultural civilization as previously understood. The people who built Göbekli Tepe, whoever they were doing so before the conditions that supposedly made large-scale organized construction possible had come into existence. The site required, by any reasonable estimate, the coordinated labor of hundreds of people over extended periods. The stone pillars, some of which weigh between 10 and 20 tons, were quarried, transported, and erected with a precision that implies technical knowledge and organizational capacity well beyond what was previously attributed to hunter-gatherer cultures of the period. The iconography carved into the pillars, vultures, scorpions, foxes, headless human figures, suggests a complex symbolic system, possibly a cosmological or astronomical framework. Göbekli Tepe does not prove that an advanced civilization existed in the Atlantic in 9600 BCE, but it conclusively demonstrates that the assumption underlying the dismissal of Atlantis, that complex, organized, monumentally capable civilization did not exist before roughly 3000 BCE, is wrong. Something capable of building Göbekli Tepe existed at exactly the period Plato specifies for Atlantis. The question of metallurgy is particularly interesting. Plato's description of orichalcum, a metal or alloy that gleamed red gold and was valued below only gold itself, has been dismissed as invention, since no metal matching the description is recognized in the standard history of ancient metallurgy. But in 2015, a team of Italian researchers analyzing Bronze Age metal ingots recovered from a shipwreck off the coast of Sicily identified a material composed of roughly 80% copper, 15 to 20% zinc, and small quantities of nickel, lead, and iron. This composition matches with reasonable precision what ancient sources describe as orichalcum. The ratio of copper to zinc produces exactly the reddish gold color Plato describes, and the alloy is metallurgically distinct from standard bronze, which uses tin rather than zinc. The identification is not universally accepted, and the ingots date to the 6th century BCE rather than to prehistoric times. But it demonstrates that the material Plato described was not imaginary. It was a real alloy known in the ancient world, and its specific properties were remembered precisely enough to describe it accurately. The hydraulic engineering described in Cretias, the concentric rings, the canals, the harbor infrastructure, is of a kind that has been demonstrated to be possible in the ancient world. The irrigation systems of ancient Mesopotamia, the canal networks of pre-Columbian South America, the water management systems of the Indus Valley civilization all demonstrate that hydraulic engineering of considerable sophistication was within the practical capacity of ancient cultures. The specific system described by Plato, rings of alternating sea and land connected by navigable tunnels, is more ambitious than anything that has been archaeologically confirmed. But it is not physically impossible. It is simply very large and very precise, requiring engineering knowledge and organized labor on a scale that, before Göbekli Tepe, seemed implausible for the period in question. The Antikythera mechanism, recovered from a Greek shipwreck dated to roughly 70 to 60 BCE, is a bronze device of such mechanical sophistication, containing at least 30 interlocking gears capable of calculating the positions of the sun and moon, predicting eclipses, and tracking multiple astronomical cycles simultaneously, that its existence required researchers to revise their understanding of ancient Greek technological capacity. Nothing comparable was known to have existed in the ancient world before its discovery. It was not a prediction of ancient capability. It was evidence that ancient capability had been systematically underestimated. The mechanism did not appear from nowhere. It was the product of a tradition of precision metalworking and astronomical observation whose earlier history we cannot fully trace. The lesson of the Antikythera mechanism, of Göbekli Tepe, of the precision of Indus Valley urban planning, of all the cases in which the archaeological record has revealed ancient capabilities that the theoretical framework said should not have existed, is that the standard model of human technological development is not a ceiling. It is a floor. We know what has been found. We do not know what has been lost. The ocean floor is, in one important sense, the last unexplored territory on Earth. Roughly 80% of it has never been directly imaged at high resolution. What has been mapped through sonar, through satellite altimetry, through the painstaking work of oceanographic survey vessels, has revealed a seafloor topography of extraordinary complexity. Mountain ranges longer than any on land, plains broader than any continent, trenches deeper than Everest is tall. And within this largely unmapped territory, in regions that were coastal or above water during the last ice age, the geological and possibly archaeological record of a period of human prehistory we barely understand lies waiting. Deep sea core samples, cylinders of sediment extracted from the ocean floor by specialized drilling equipment, have become one of the primary tools for reconstructing the climate history of the past 100,000 years. The sediment layers in deep sea cores record, in their chemical composition and microfossil content, the temperature, salinity, and biological productivity of the overlying water at the time of deposition. By reading these layers, researchers can reconstruct the history of climate change with a resolution of decades in some cores, centuries in others. And what those cores reveal consistently is a world in far more rapid and dramatic transition during the post-glacial period than the standard models of human prehistory were built to accommodate. A core extracted from the seafloor of the Gulf of Mexico in the 1990s revealed a sharp sedimentary boundary at a depth corresponding to approximately 12,900 years ago, the onset of the Younger Dryas. Above the boundary, the composition of the sediment changed abruptly. The proportion of freshwater indicating microfossils increased dramatically, and the geochemical signature of the surrounding water shifted in a direction consistent with a massive influx of cold fresh water. This is interpreted as evidence of the catastrophic drainage of North American proglacial lakes into the Gulf of Mexico, and it is consistent with the hypothesis that this drainage triggered the rapid climate disruption of the Younger Dryas. The boundary is sharp, not a gradual transition, but an almost instantaneous shift in the geological record. Something happened very quickly. In the waters off the coast of the Indian subcontinent, bathymetric surveys have revealed extensive areas of continental shelf at depths between 50 and 100 meters that would have been exposed during the last glacial maximum. These shallow shelves, now submerged, were once coastal and potentially inhabited lowlands, the offshore extensions of the Indian subcontinent that existed before post-glacial sea level rise. The Gulf of Mannar between India and Sri Lanka, and the Palk Strait, which today connects the two bodies of water on either side of the Sri Lankan land bridge, were both above water during periods of lower sea level. These regions have not been systematically surveyed for archaeological material, partly because the scale of the task is immense, and partly because the academic infrastructure for such surveys has only recently begun to develop. In the Mediterranean, underwater surveys have documented submerged prehistoric settlements with increasing frequency. Near the coast of Greece, in the Bay of Lambayana in the Peloponnese, a team of researchers documented a Neolithic underwater site in 2014, a settlement submerged by sea level rise roughly 5,000 years ago, preserving stone walls, floors, and artifacts beneath a few meters of water. Similar sites have been found off the coasts of Israel, Croatia, and Turkey. These sites by themselves are not anomalous. The Mediterranean shoreline has changed significantly since the Neolithic, and underwater archaeological sites from that period are to be expected. What they demonstrate is that the methodology for identifying and investigating submerged prehistoric sites exists and is producing results. The Atlantic presents a different challenge because the depths involved are vastly greater. The continental shelves of the Atlantic, the regions of ocean floor that were above water during the glacial maximum, drop off into abyssal depths beyond the shelf edge. Any settlements or structures that existed on the Atlantic coastal plains of 9,600 BCE at sea levels 120 meters below current levels would today lie at the outer edge of the continental shelf or in the deep ocean basin beyond. Surveying these regions for archaeological material requires robotic vehicles, specialized sonar, and significant funding, resources that are rarely directed towards speculative archaeological targets. But some surveys have been conducted, and some results have been anomalous. Robert Ballard, the oceanographer who discovered the wreck of the Titanic and who has conducted extensive underwater surveys in the Black Sea, described in 2000 the discovery of what appeared to be a submerged ancient shoreline in the Black Sea at a depth consistent with the pre-breach lake level. Along this ancient shoreline, Ballard's team found what appeared to be structures, stone features at a depth of approximately 300 meters, in an area that would have been dry land roughly 7,000 years ago. The discovery was reported in National Geographic and generated significant interest. Subsequent investigation has been limited, and the nature of the features, whether natural or constructed, has not been definitively established. The pattern that emerges from these scattered data points is not a proof. It is a methodology, the beginning of a systematic approach to a question that has been treated for most of the history of Atlantis scholarship as either a matter of ancient text interpretation or a matter for enthusiasts rather than scientists. That is changing. The tools now exist to survey the ocean floor systematically, to date sedimentary layers with precision, to extract ancient DNA from prehistoric material, to model past sea levels with accuracy. The question of what lies beneath the post-glacial ocean is not fundamentally different from the question of what lies beneath the Saharan sand or beneath the jungle canopy of the Yucatan. It is an empirical question. It has an empirical answer. What is left when everything has been considered is not proof and not disproof. It is a shape in the historical record that corresponds with enough precision to be worth examining carefully to something that may have been real. The outline of a civilization, its location, its structure, its date, its destruction, preserved in the writing of a philosopher who was not given to invention, sourced from priests who maintained archives of extraordinary antiquity, transmitted through a chain of custody that, while imperfect, is no more imperfect than the transmission of many ancient documents we accept without difficulty. The question of Atlantis has been distorted by the extremes it attracts. On one side, the enthusiasts who see it everywhere, in every megalithic structure, every underwater formation, every ancient myth, and who are willing to accommodate any evidence while dismissing any contradiction. On the other side, the skeptics who have dismissed it so completely that even legitimate questions about ancient seafaring, prehistoric civilization, and post-glacial archaeology get tainted by association with the more speculative versions of the Atlantis claim. The territory between these positions is where the serious inquiry lives, and it has not received the sustained, methodical attention it deserves. What would constitute evidence for Atlantis? This is not a rhetorical question. It has a concrete answer. A submerged site in the Atlantic basin dated to the period around 9600 BCE, showing clear evidence of organized construction, worked stone, architectural regularity, the presence of human artifacts, at a depth consistent with post-glacial sea level rise, in a geographical position consistent with Plato's description, would constitute evidence. Not proof, but evidence. The kind of evidence that shifts the inquiry from the philosophical to the empirical, from the category of interesting speculation to the category of something that must be explained. Such a site has not been definitively found, but the ocean floor has not been definitively searched. The continental shelves of the Atlantic, the regions that were above water during the period in question, have not been systematically surveyed for archaeological material at the scale and resolution that would be required to find a prehistoric coastal settlement. The technology to conduct such a survey exists. The scientific rationale for doing so has become considerably stronger over the last 2 decades. What is lacking is the institutional and financial commitment to treat the question as a legitimate scientific problem rather than a cultural curiosity. The history of archaeology is a history of revisions. Sites that were legendary became real. Places that had been classified as myth acquired addresses. Troy, which Heinrich Schliemann's contemporaries considered a poetic fiction, turned out to be a real city with 9 layers of occupation, the lower levels dating to the 3rd millennium BCE. The palace of Knossos on Crete, the center of the Minoan labyrinth tradition, was discovered in 1900 by Arthur Evans at a site that local tradition had pointed to for centuries. Machu Picchu was not unknown to the people of the surrounding region when Hiram Bingham arrived in 1911. It was well known locally, preserved in oral tradition, waiting to be recognized by those with the means and inclination to look. The Younger Dryas impact hypothesis, which proposes that a cosmic airburst or impact event contributed to the rapid climate change of 12,900 years ago, has accumulated a body of supporting evidence that continues to grow. A study published in 2018 in the journal Scientific Reports described the discovery of a platinum anomaly in the sediment layers of a site in South Africa, dated to the onset of the Younger Dryas, consistent with similar platinum anomalies found at sites across North America, Europe, and the Middle East from the same period. Platinum is associated with cosmic impactor material. Its presence in a geographically widespread sediment layer of the same approximate date suggests either a cosmic impact event or a series of related events affecting the entire planet. An impact of sufficient scale to deposit platinum markers across 4 continents and trigger a millennium of climate disruption would have been capable of destroying any coastal civilization existing at the time. The Sahara, which was not desert in 9600 BCE, but a landscape of grasslands and lakes, dried out rapidly beginning around 5,500 years ago. The populations that had lived in the Saharan interior during the African humid period moved northward to the Mediterranean coast, eastward to the Nile Valley, westward toward the Atlantic. Some of those migrations contributed to the population of dynastic Egypt. Some of them contributed to the populations of North Africa, the Iberian Peninsula, and sub-Saharan Africa. They brought with them the memory of a wetter, more habitable world, preserved in their myths, their languages, their cosmologies. How much of what they carried in memory reached Egypt's temple archives, and what those archives eventually contained, we cannot know. Most of what those archives contained has been lost. The Library of Alexandria, which represented the largest accumulation of ancient knowledge in the Mediterranean world, was not destroyed in a single catastrophic fire, as the popular narrative holds. It declined gradually over centuries, through neglect, through political disruption, through the attrition of scholars and funding. What it contained at its height, papyrus scrolls numbered in the hundreds of thousands representing the accumulated textual knowledge of the Greek-speaking world, is almost entirely gone. What it may have preserved from even older sources, Egyptian temple archives, Phoenician navigational records, Babylonian astronomical observations, is gone with it. The silence that surrounds Atlantis is partly the silence of a civilization that may have vanished beneath the sea, but it is also the silence of libraries that burned, of archives that were scattered, of oral traditions that were interrupted before they could be written down. Plato wrote at a moment that was already late. Already in his time, the thread of transmission was long and thin, from the Egyptian priests, through Solon, through generations of Critias's family, to the dialogue he was composing. He chose to record what had been given to him, with the precision and specificity that marks all of his serious work. He insisted twice that it was not a story but a history. The world has spent 24 centuries deciding what to do with that insistence. The answer still is incomplete. What lies beneath the ocean is not silence so much as patience. The patience of depth, of sediment, of geological time. It is waiting for instruments precise enough to ask it a question it can answer.